Okay, welcome back to part 2. I stopped it because I didn't want the video to be too long. Alright, so this is the last example we did. We're talking about integrating with a combination of a linear expression, composition with a linear expression. Alright, we're going to find the integral here of 4x minus 2e to the 1/3 x. First thing I did was I wrote down the integral sign with the dx here, and then I'm going to split them up again the way I've been doing the whole time, where I'm going to have the integral of 4x with respect to x, and then the integral of the 2e to the 1/3 x with respect to x. So the integral of 4x would be add 1 to the exponent divided by the new exponent, so 4x squared over 2, and the integral of 2e to the 1/3 x. So you have your 2e to the 1/3 x because the integral of e to anything, of course, would be e to the anything. But then we have to do this additional bit where we want to multiply by 1 over the slope, and the slope there is 1/3. So that's times 1 over 1/3 plus your constant of integration. And then the next step, I'm going to clean that up. So 4x squared over 2, of course, is just 2x squared. Dividing by 1/3 is the same as multiplying by 3, so that becomes 6e to the 1/3 x plus c. We're done with that example. Let's take a look at number 7. I'm going to first, I pulled that 3, which was in the numerator, out to the front because it's just a constant. And then I change the square over the square root of 2x plus 1 to be 2x plus 1 to the power of negative 1/2. All right? So I'm going to integrate. So I'm going to add 1 to that exponent, divide by that new exponent. So the 3 carried down. Negative 1/2 plus 1 is 1/2, divided by 1/2, times 1 over the slope. The slope here is 2, plus the constant of integration. Then here, again, dividing by 1/2 is the same as multiplying by 2, so that 1/2 and that 3 became a 6, times the 1/2 plus the constant of integration, and then the 6 over the 1/2, you end up with 3 times 2x plus 1 to the 1/2 plus c, which you can then clean up to be 3 times the square root of 2x plus 1 plus c. Remember, whenever you're doing these integral problems, you can always check them by finding the derivative of this, of your answer, and check to see if you get the original question there. Number 8. All right, I think this is an IB question. We're going to find the derivative function f. Oh, sorry. The derivative of the function f is given by this. So this is our derivative function, and we're going to find f knowing that it passes through 0, 4. Okay. So the first thing here is I know that f is going to be defined as the integral of all of this, of the derivative. So I split it up. I have the integral of e to the negative 2x with respect to x, and then the integral, and notice that I called that 1 minus x to the power of negative 1 dx. Now, that's a problem. I really shouldn't have done that, because if you start to follow the, let me back up, sorry. Here, with this e to the negative 2x, of course, the derivative, the integral would be e to the negative 2x, and then I have to multiply by 1 over the slope, so that's where the negative 1/2 came from. Now, you'll notice here that 1 minus x to the negative 1, if you add 1 to that exponent, you're going to end up with 0. That's no good. So what you really need to consider is whenever you have 1 over anything to the power of 1, it's the natural log function. Okay, so that's really the natural log of 1 minus x, but the slope of this expression 1 minus x is negative 1. So that's tricky there. The slope of this linear expression inside is negative 1, so I had to divide by that slope. Add the constant of integration. Cleaning it up a little bit, I just pulled that negative out in front, called that negative natural log of 1 minus x plus c. All right, now I know that this function passes through the point 0, 4. That means that when x is equal to 0, f of x is equal to 4. So up here, I'm going to say that f of 0, so here I'm substituting 0 into this expression I just found, negative 1/2 e to the 2 times 0, or it should be a negative 2 times 0, minus natural log of 1 minus 0 plus c, and that's equal to 4, since it goes through 0, 4. Well, negative 1/2 times e to the power of, again, let's just say negative 2 to the 0, that's just going to be, because e to the power of 0 is 1, so from that expression it's just negative 1/2 times 1, minus natural log of 1 plus c is equal to 0, is equal to 4. All right, here we have then negative 1/2, and the natural log of 1 That's equal to 0. Because, remember, a natural log of anything, this means the base, which is e, to what power is equal to 1. Again, the base e to what power is equal to 1? Of course, that's 0. Plus c equals 4. And so c equals 4 1/2. And now that I know c, I go back to my f of x. I have negative 1/2 e to the negative 2x minus natural log 1 minus x plus 4 1/2. And we're done with that problem. All right, here I just have a summary of all of these properties. These are not given to you on the IB exam. You need to recognize whenever you have a linear expression to a power, or e to the power of a linear expression, or 1 over a linear expression. Here's that natural log business, and so on and so forth. Last example. The gradient of any curve on this point is given by f sine 2x plus 3. So that basically is your gradient function, or your slope function, and the curve passes through this point. So this is just like the previous example. So I'm going to integrate this 5 sine 2x plus 3 with respect to x, and that's going to be 5 times the cosine of 2x plus 3 plus 3. And notice the 2 showed up because I had to divide by the slope of 2. And then the negative showed up because the integral of sine of x was negative cosine of x. Okay, so that's my integral function with the constant of integration. And I know that f of 0 is equal to 3/2 cosine of 3. So here I'm plugging in the 0 into this expression, and I'm setting it equal to 3/2 cosine 3. So 2 times 0, of course, is 0 plus 3, so I just have negative 5/2 cosine of 3 plus c is equal to 3/2 cosine of 3. Now to solve for c, because these are really constants here, negative 5/2 cosine of 3, that's a constant. Same with this one, 3/2 cosine of 3. I'm going to add, I want to isolate the c, so I'm going to add this whole thing, this 5/2 cosine of 3 to both sides, like so. You can see on the left-hand side that those are going to cancel, so you're left with c equals, well, 3/2 plus 5/2 is 8/2, which is 4 cosine of 3. And just like we've been doing before, once you find your c value, go back up to your f of x expression and plug it in the 4 times cosine of 3. Okay? That's it.